Here's problem 38.6. A screen is placed 1 meter behind a single slit, which is illuminated with light of wavelength 650 nanometers. If the distance between the first and second minimum in the diffraction pattern is 1 centimeter, what is the width of the slit? So we have a slit of a certain width, and some point away we have a screen. So we have some kind of angle to the first minimum, and we could call that position Y if the screen is a distance L away. And based on this, the screen is 1 meter away, so we have L is equal to 1 meter. Our wavelength is 650 nanometers. And we're told that the difference between the first and second minimum is 1 centimeter. So the change in Y between m equal 1 and m equal 2 is 1 centimeter or 0.01 meters. And we want to find the width of the slit, A. We know in general that A sine theta is going to equal m lambda for the minimum order on either side, m equal to plus or minus 1, plus or minus 2, and so forth. For small angles, the sine of theta will be approximately equal to the tangent of theta. In this case, the tangent of theta is equal to y over L, if we look at that triangle there. So we really have that A times y over L equals m lambda for small angles. And if we want to find A, we could say that given that we know what the distance between the first and second minimum are, and A being a constant, L a constant, and lambda being a constant, we could say that A over L times the change in Y is equal to the change in M times lambda. So actually A would equal the change in M times lambda times L over delta Y in this case, where we happen to know what delta Y is. The delta M is between one minimum and the next one, next successive one, so that delta M is actually equal to 1. So we have that A is equal to 1 times lambda, which is 650 nanometers, times L, which is 1 meter, over delta Y, which is 0.01. So this will be 6.5 times 10 to the minus 5 meters, or about 0.65 micrometers. That's our answer. The width of the slit is 6.5 times 10 to the minus 5 meters.